All right, class, let us begin for the first lesson in Chapter 5, Comparing and Ordering Rational Numbers. So rational numbers is something we have already gone over and talked about. If you remember, rational numbers are any numbers that can be basically written as a fraction. So it does include whole numbers, it includes certain decimals. We did cover what that includes. If you want to go back and look at your notes, or if you remember, that's fine. You can find more information, of course, about this on page 236. Let's begin. So first we start off with a definition. So we're starting off today, we're going to be learning about LCM, least common multiple. Before we get to that, though, we need to learn what a multiple is. A multiple is a number. A multiple of a number is the product of that number and a non-zero whole number. Product meaning multiply. So sometimes definitions don't make much sense until we actually see some examples. So an example, the multiples of 5 are 5, 10, 15, 20, 25, 30, and so on. Basically, you could just count by fives, and I think you get the idea that, you know, it's going to be like what it's going to be. So, but just to explain how the definition applies to this, it's saying so the multiple of a number, like 5, is the product of that number times, you know, any non-zero whole number. So you could say 5 times 1 is 5, 5 times 2 is 10, times 3, times 4, times 5, times 6, you get the point. So next, let's look at an example number 8. So multiples of 8, you have 8, 16, 24, 32, 40, 48. So you're seeing that these are all multiples of 8, and they keep going, of course. The multiples don't ever stop. Unlike factors, where you're looking at the little pieces that make up a number, when you're looking at multiples, they don't stop. Factors have a certain, it has a set number of factors. It might have a lot of factors, but it's going to come to an end of how many factors can go into it. Multiples, though, can go on forever. All right. I'm not going to make you list all the multiples, though. Don't worry. Least common multiple, or as we're going to call it from here on out, LCM. This is similar to GCF, but almost like going in reverse. So you're going to notice some similarities, but it's going to do the opposite. If you have a really good grasp of what the GCF is, then you should do pretty well on here. A great thing to do is to look back on your test and make sure that you've got a concrete understanding back in Chapter 4. We went over GCF. If you don't, it's easy to get these two kind of mixed up and they blur together. So if you've got one concrete, this one can't blur with it if you understand it. So this one, it helps it become more concrete, okay? So try to make sure you understand GCF as we're going over this. So here we are told to find the LCM. And I'm going to show you two different methods, similar to what I did when we were going over this with GCF. There is the list method where you list out the multiples until you find the smallest multiple they have in common. You could list out multiples, and for 4 you've got, of course, 4 and 8 and 12 and 16 and 20. And most of you at this point know what multiple they have in common. It's going to be 20. Some people are like wondering, well, how do you know that? Well, let's work it out real quick just so you can see that it is 20. You have 5, 10, 15, 20. See, 20 is the first multiple they have in common. A way that I knew this was because I know all the multiples of 5 end in either 5 or 0. This is the first multiple of 4 that ends in 0. So it's going to be the first multiple they have in common. Now they have other multiples in common like 40 and 60 and 80 and 100. These are all multiples of 4 and 5. But we're looking for the one they have in common that is the smallest. That's where the L comes in, the least. So here we're going to use prime factorization to help us find it. So if you remember prime factorization, you get 2 and 3. Over here you get 2 and 4. Sorry, you get, my bad. You get 4 and 4, and 2 and 2, and 2 and 2. Okay? So we're going to write down the prime factorization for these numbers. So my first one, the prime factorization is 2 times 3. For my other prime factorization, I have 2 to the 4th power, okay? So if you remember, with the GCF, we would say, what's the GCF of these two numbers? I hope you can tell that it's 2. You would say, well, what number do they have in common, and which one has the smaller exponent? 2. So that's the GCF. It's 2. Okay? If they had other numbers together in common, we would then multiply those to find the GCF. LCM is the exact opposite. You actually choose one of each number, meaning I have a 3 here, and it's the only 3, so I'm going to choose him. I have 2 2's here. Which do I choose? You choose the one with the bigger exponent. So in GCF, we choose the smaller exponent, but in LCM, we choose the larger exponent. So you choose this one. And then you need to multiply them together. So I have now 2 to the 4th power times 3, which is equal to, well, 2 to the 4th power is, of course, 16. And 16 times 3, what is that going to be? I believe it's 54. So 54 is the LCM for this. Over here, I forgot to put down 20 in a box, but 20 is the least common multiple over there. So you can use prime factorization, which is important once we get into this next part. So here we have some simple things right here. We have finding the LCM for these two right here, and these ones involve variables. So let's go over this carefully. Let's remember how to find the LCM for some numbers. So again, we could list out all of the multiples and then find the ones they have in common, or you could use prime factorization. I'm going to use prime factorization again. I'm going to put my 12 right here and say, well, that's 2 and 6, which is the same as 2 and 3. So I have 2 squared times 3 for that one. And for 15, I would have 3 and 5. So I have, look for my line here so I can tell that that's separated. So over here I have 3 and 5. So remember, you need one of each of the numbers, basically one of each of the bases. So I have a 2, a 3, and a 5. So over here I'm going to put 2, and you pick the larger exponent, so you picked the second. That's the only one to choose from anyways. You pick 3, and it doesn't matter which 3 you choose because they're both the same, so you just pick one of the 3's, and you pick the 5. There's only one 5, so it doesn't matter there, so you pick that. So now you need to find out what the answer to this is. So what's 2 times 2? That's 4. 4 times 3 is 12. 12 times 5 is 60. So this is equal to 60. Now we're not done because now we need to go back and find it for the variables. Thankfully, the variables work a lot like the prime factorization, but it's already been worked out for us. And the good news, we're not going to have to multiply like we did right here. We're just going to leave the variables as is. So I have an x right here, and I'm going to choose the x with a larger exponent. So I have x squared. I have a y, and there's only one y, so he just tags along. And I'm going to put my number, remember that I needed to find the LCM for these, so I put my 60 right here. That is the LCM for that right there, okay? Again, if you have some notebook paper that you can space this out more, if you want to do that, that's fine. Just so long as you can read your notes, that's the key thing for you to be able to read your notes. Okay, so again, we can make some prime factorization stuff. You can do the prime factorization, but I know the prime factorization for these numbers. I'm just going to go ahead and tell you that that would be 2 cubed compared to 2 times 7. So I have some 2's to choose from. Which 2 do I choose? The one with the bigger exponent. So I can bring that down. I'm going to put a line right here just to make sure I keep my work separated. I'm going to bring my 2 down to the 3rd times 7. Okay? So, what do we end up with once we do this? So we're going to say, well, 2 to the third isn't that 8? What's 8 times 7? Well, isn't 8 times 7 56? Yep, so we get 56. Now I need to pick which letter I need. Well, they both have m, but which one has the bigger exponent? To the fourth. So my answer is 56m to the fourth. And that's the answer. Pretty simple. All right, let us flip to the other side. Wah. Yeah. All right, this is also pretty simple. And the next things we're going to do has less letters involved, just more numbers right here. We're comparing, and these are all considered rational numbers because they are, in fraction form. And this is what it means by the whole chapter is called comparing. And you'll see why we learned the LCM in just a minute. This first comparing problem should be very easy. Remember, you can always pause the video if you need to copy stuff down, feel free. But this first comparing problem, we have 3/8 compared to 7/8. Which is larger? I hope you know fractions well enough to know that 7/8 is the bigger fraction. So you're going to put that like so, okay? That is the larger fraction right there. All right, next right here, we have -5/9 and -3/9. I hope you remember how negative numbers work, because when both numbers are negative and you're comparing, you choose the smaller looking number. So 3 is smaller looking. So we actually say that this one is greater, okay? -3 is greater than 5, okay? Now, we do run into a slight problem on letter C. You cannot compare these two fractions because they do not have common denominators. Without common denominators, you cannot tell for sure which one is bigger. Now, some of you might be familiar enough with 1/3 and 1/2 to know exactly which one is bigger. But for us to know for sure, we're going to find a common denominator. Now, a common denominator relates to LCM. You're looking for a multiple that the denominators have in common. So what's a multiple of 2 and a multiple of 3 that they share in common? Well, that would be 6. That would be 6. So we're going to say I have, with my new fractions, okay, I'm going to put a 6 down here and a 6 down here. Now, you can't just go and put a 1 here and a 1 here. That doesn't, think about that. That wouldn't make sense. 1/2 turns into 1/6. That doesn't make sense. So we're going to do the same thing we did when we made equivalent fractions. We're going to change it to a fraction that is equivalent to 1/2. But it has to have 6 in the denominator. What's a fraction equal to 1/2 with 6 in the denominator? Well, isn't it just 3/6? And same thing over here. I have 1/3. What's a fraction that's equivalent to this if 6 in the denominator? What has to go on top? It goes 2. So which fraction is bigger? Ding, 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 ding. So that means 1/2 is bigger. And some of you might have already known that. That's fine. But when you get to fractions like this, which one is bigger? Can you tell? Anyways, let's find out which one's bigger. So what's an LCM for these two? Well, if you happen to notice that both of these are prime numbers, with them both being prime numbers, the prime factorization, this one's going to be 5, this one's going to be 11. So if you put those two together and multiply them, you get 55. Yeah, that's the LCM for these two. So if you try to find a common denominator, you will come across 55 is the first one and the best one for us to use. Whoops, 55. Almost made a mistake. 55. So the question is, what did I multiply my 11 by to turn that into 55? I multiplied it by 5. So do the same at the top, and you end up with 45. Over here, you multiply this by 11, so you get 44. Oh dear, which one is bigger? Ding, 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 ding. This one is. But I want you to notice something. This thing is only 1/55th bigger. Only 1/55th bigger. That is very small. 1/55th. So there's no way you could have just known that that was bigger, okay? So you got to find a common denominator. All right. Last section for us, fractions and decimals. All right, and this is video, or lesson 5.2, fractions and decimals. So what we're going to be taking a look at, you can go also to your book and take a look at page 241. All right, so we've got two things we're going to do here, really just two things. You're going to convert fractions to decimals and then back the other way, so decimals to fractions. So first we're told to, for example 1, write each fraction or mixed number as a decimal. And this is actually pretty easy. The math is very simple. You just got to remember what to do in these situations. And this is very important to what we'll be doing later in this chapter. So please pay close attention. For our first example, we're going to be looking at this. We have 1/4. So I got to convert 1/4 to a decimal. Well, the way that we convert a fraction to a decimal is by using long division. So we take this, you tip it over. The top number goes under the hood, the bottom number goes on the outside. So you would have 4 on the outside going into 1. We all know that that's an impossibility. There's no way 4 can fit into 1. So we're going to have to put a decimal right here, a decimal at the top. You put a 0 in. So now we say, how many times can 4 go into 10? Well, it can go in there 2 times. Multiply back, you get 8. And then you would subtract to get a 2. 4 can't go into 2, so you make another 0, you bring it down. You say 4 goes into 20 5 times, and that one works out perfecto. Okay? It works out, so we are done. All right? So our answer is going to be, I put a 0 in the front, so you have 0.25, okay? And you can just box that in right there like that. So there you have 0.25. All right, next over here, we have the 1 3/8, okay? Now this is important for your answer. If you want, I might even recommend this, to go ahead and just make an answer box like right here. So if you make your answer box right here, you're just going to put a 1 in it. And then I go ahead and put my fraction bar. It's going to have some, sorry, not fraction. We're converting them to decimals. I'm being silly here. Put your decimal. Go ahead and put your decimal right there, okay? So I need to convert now this, I need to convert to a decimal. The whole number stays a whole number. Doesn't matter which way you're going. If you got a whole number like 1, it's going to stay 1. So there's no changing that. Now just find what this is. So we say 8 goes into 3 how many times? Well, it can't go into 3. Put your decimal, place your decimal, 0. 8 goes into 30 3 times. Multiply back, you get, you get 24. Subtract, you get 6. Bring down a 0, you get 60. 8 goes into 60 7 times. Multiply back, you would end up with 56. Subtract, you get 4. Bring down a 0, you get 40. 8 can go into 45 times, and it fits in there perfectly. So you end up with 0.375. So 0.375. Your final answer, though, is 1.375 because we had that 1 up there. All right, next. We just have, I think, just 2 more of these, and then we'll get to the next example. So this is important to see a fraction like this. This is going to be a repeating decimal. So let's take a look at when we convert this. We put 3 into 1, okay? Can't go into 1, so you put a decimal. It goes in there 3 times. Multiply back, you get 9. You get 1, bring down a 0. Goes into that 3 times. Multiply back, you get 9. You get 1. You bring down 0. You get 10. 3 into that 3 times. Are we seeing what happens here? We get 0.3333, and it's going to keep going. It's not going to stop. If you notice a pattern up here and you notice a pattern down here, it means it's going to keep repeating. So what we do is, instead of having to write out all those 3's going on forever, you just need to write down 3 with a line over it. And I put a 0 out front, and I box in my answer. Now when you box it in, make sure that you don't draw over the line. Make sure you give enough space to go up. So I don't know why I have that line there. So put a line over the 3. Okay. A different type of repeating decimal is one like this. This is going to highlight 2 other things about repeating decimals. So let's take a look. I have 22 going into 21. I would go ahead and write that as, put my decimal, bring my 0 in, okay? So 22 goes into 210. I believe it's 9 times. Multiply back, you end up with 198. Okay, you're going to get 198 if you multiply back. You would then subtract, and you would get 12. Okay, so we have 12. Bring down another 0. 22 goes into 12 5 times. Multiply back, and you will get 110. You subtract, and you end up with 10. Bring down a 0, and then you'd say 22 goes into that. How many times? You would get a 4. Multiply back, and you're going to get an 88. Subtract, you get a 12. You bring down a 0. Hey, wait a second. Haven't I done this thing where I go into 12 already? Just to make sure, let's just work it out just a little bit more. If I were to work this out a little bit more, I'd say, well, it goes in there 5 times again, multiply back, and you would get the 110, and then you get you subtract, and you get 100. Once you bring, you get 10. Put the 0 there, and oh dear, I think this is going to keep repeating. But the question is, what's repeating? It's not just one number, it's 2 numbers. Okay, and the 9's not repeating, but it's the 5 and the 4. 5, 4, 5, 4. And this is going to keep happening again and again and again. So when we write this, we need to put 0.954 with a line only over the 5, 4. If you were to put that line over the 9, it would be wrong. If you put a line only over the 5 and you left off the 4, it would also be wrong. So you got to work it out like that, okay? Now, I'll give you some good news. I will not give you many problems like this that have a long thing you need to work out, but you will have a few. And if you are lazy and you don't work it out, I hope you fail. I really do. So don't be lazy, do the work, okay? All right, next we have this right here where we are told to write each decimal as a fraction or mixed number. And you need to put it in simplest form. Now this is real easy. What you do to turn a decimal into a fraction is you just take that number and you put it over 10. Now the reason why you put it over 10 is you could look at it for 2 reasons. One is this is actually, it's not, we technically should not say 0.3. We do because it's just easier, but this is actually pronounced 3/10. 3/10. Well, 3/10 can be written as 0.3, but it can also be written as 3/10, okay? A simpler way that a lot of students look at it is like this. You take whatever number you have past the decimal. See the decimal? That 3 is after the decimal. You put it over a number 1, and it's going to have the same number of zeros as you have numbers past the decimal. We have 1 number past the decimal, so we put it over 10. Another way to look at it is this 3 is in the tenths place, so you put it over 10. Okay? Let's take a look over here. Here we have a 4.24. Now, this whole number out front is going to remain a whole number, so you can once again put your whole number there, and we are going to get some kind of fraction answer. So I would take 24, and what do you think we're going to put it over? Not 10 this time, because we have 2 numbers past the decimal. The 4, which is the last digit, is in the 100ths place. You're going to put this over 100. Now we are told to put in simplest form, so if you go and write this down over here, you're actually going to get a wrong answer, because this is not following directions. The number might be right, but you haven't finished the work. What can go into it, okay? Well, it turns out that to simplify a fraction, we've done this already. 4 goes into both of them. 4 goes into this one 6 times, while it goes into this 25 times. I can't reduce any more than that, so I end up with 6 25ths. 4 and 6 25ths is my answer, okay? Last two examples. Last three. Here we have 0.05. Now a lot of students just think, oh, I got one number, I'm going to put that over 10. Well, you don't do that. This 5 is actually going to go over 100 because the 5 is in the 100ths place. You got to count that 0 right there because it's after the decimal. Okay, you don't have to put that 0 up here because it's not really needed. It would look weird to put 0.5, so don't do it. This can reduce to 1/20th. Yay. Uh-oh. A repeating decimal. Now, a repeating decimal does not work quite the same way. What you do is you look at how much numbers you have repeating. Okay, we just have this one number repeating. So since I have one number, I am going to think of it as kind of like you could put it over 10, and you're going to put the 3, except you've got to minus 1 from that. So it actually becomes 3/9. And 3/9 reduces to 1/3. If you flip back to the front page of what we did, you'll remember that we turned 1/3 into a decimal, and that was the decimal it was. So they convert back and forth perfectly. So what you do is you put it over that, you're going to subtract the 1, there you go. Okay? So over here, what we have is we got 27, so we're going to take 27, and we would normally put that over 100, but because it's repeating, we need to subtract a 1 from the bottom. So we now have 27/99, okay? 27/99. Can this reduce? Yes, it can. 3 goes into both of these. 3 goes into, actually, 9 goes into both of these. 9 goes into this number 3 times, and you would get 3, and it goes into this 11 times, so you would get 11. And that's pretty much it is. Watch the video carefully and ask questions in class. Bye-bye.